I've long been interested in sea level rise, in part because I've always been kind of a beach rat. But more importantly, sea level rise is really one of the most certain and direct impacts from climate change. And in a place like here in the Northwest, where we have literally thousands of miles of shoreline, we have major urban centers, we have key industries, our ports. Obviously, we've had a lot of discussion about the shellfishing industry. We have valued cultural traditions and a tremendous diversity of habitats and ecosystems. It matters. I, in my career, get asked a lot by coastal managers and others, so how much is sea level going to rise and how fast? What does it mean for this community or that ecosystem? How much sea level rise should we prepare for? And there's a lot of information out there. I'm going to give you as much as I can in a short amount of time, hopefully without overloading you. But really, I have to begin answering those questions with just two words. It depends. It's very hard for some people to hear that. It's probably your editors probably don't want to hear that either. It's the beginning of your stories. But as you'll see throughout my presentation, that with a lot of nuances, it actually it really does. I'm going to start with just a very brief overview of what are the things that are comprising sea level rise. Now, a lot of the big picture numbers that you hear from, say, the IPCC, the projections for sea level rise over time, generally refer to global or so-called eustatic sea level. And that's due largely to the thermal expansion of our ocean waters and to input of water from land-based sources of ice melting, or glaciers in our ice fields. That's kind of what fills up the bathtub, if you will. Now, importantly, that global eustatic change is not uniform across the planet. There are a lot of other factors that will increase its variability depending on where you are. Things like ocean circulation and wind patterns, even the Earth's rotation. So for a regional perspective, it's important to understand that, and I'll talk a little bit more about this region and what some of those implications are. But it's also important to know, especially if you're thinking about sea level rise in a particular area and you're planning for it, that there are some other factors that affect so-called relative sea level rise, or sea level change, I should say, because in some places you may actually see sea level decline due to some factors. And that can be things that change the elevation of the coastal lands, tectonic shifts, isostatic rebound from the last glacial days. There also are some natural processes that can affect relative sea level, and that includes things like sediments, geomorphological changes. There are some natural processes called marsh accretion I'll talk about. So those are all things that, to one extent or another, are going to change the relative amount of sea level rise that coastal communities or ecosystems should be concerned about. And it's also, I think, very confusing for a lot of people because there are a lot of numbers out there for what we're likely to see in terms of sea level rise. Now, a lot of the studies, this is a comparison across a number of studies in the peer-reviewed literature. These are generally showing kind of the global projections, not predictions, mind you. These are projections for sea level. We don't have a crystal ball. We don't know what is going to happen, but these vary based on here's one place where those two words come into play. The differences depend on a lot of things. This number, the lower numbers here, you'll probably recognize that was from the last IPCC 2007 report. Since then, there have been a number of studies that do project higher rates. But it depends on, first of all, on the emission scenarios that they're looking at. Generally, from the range, the lower ends of the range is if we're optimistic about what we can do internationally in terms of lowering greenhouse gas emissions. And on the upper end, it's kind of more the high end of emission scenarios. But it also depends on the types of studies and analyses they used to make these projections, the types of models they used, whether they're fully model-based or semi-empirical, a lot of kind of differences in the studies. And there were differences in assumptions based on things like the rate of how much water we're going to see entering the ocean from things like melting ice fields in Greenland and Antarctica. And actually, it's one of the differences that we see in some of these later projections that are higher than the IPCC numbers, and that there's been some evidence of some dynamic changes in land-based ice that have scientists to believe that the contribution is going to be greater than once thought. But there are some of these regional factors, both localized factors and factors that affect the eustatic changes in different areas. And as a result of that, and there are some key ones here on the West Coast, West Coast states actually asked the National Research Council to do some projections specifically for California, Oregon, and Washington. And the numbers here I'm showing you are mainly for Northern California, Washington, Oregon. There's some different projections for Southern. A lot of these were included, some of the work from the peer-reviewed literature that I highlighted previously, but they also do take into consideration some of the more regionally focused factors, and I'll talk about those shortly, but you may be surprised to see some negative numbers here. These are their general projections over time. And that has to do with some factors that actually, at least in the near term, might be contributing to our lands actually rising faster than the eustatic rate of sea level. Now, those negative numbers do not by any stretch mean that parts of this region are out of the woods. And in fact, a lot of these projections, in many ways, you have to look at them also based on the changing rate of global eustatic sea level over time. I put the source of this study. It's a very interesting, useful report for you to read. It talks about the science I'm going to mention in much greater detail. And so hopefully that'll be a helpful resource for you. But in terms of some of those regionally specific factors that affect relative sea level in this region, and you probably can't see the numbers there, but maybe the arrows, the graphic on the right shows the current rates of relative sea level rise in the region based on tidal gauge measurements. And the down areas show areas where actually, yes, that relative sea level is declining. Places like northern part of the Olympic Peninsula, we're seeing tectonic uplift. So the land elevation is actually rising relative to the amount of eustatic sea level. Other areas, much of Puget Sound is subsiding for some similar reasons. A big wild card in this region is what might happen if we see a major earthquake, and for example in the Cascadia subduction zone. There's suggestion that if we see a big earthquake, we could actually get some immediate massive subsidence and thus very, very significant sea level rise. Now, if that were to happen, I think we have, as a society, quite a bit of things to worry about, not just sea level rise. But I do put it out there as a possibility. In terms, again, of some of the regionally specific factors, there's some interesting factors here that are affecting that relative variation in the eustatic numbers. One of them, and this is something I really unfortunately can't describe very well in detail because it's complicated, but there are these so-called fingerprints of sea level rise based on melting ice input. And in very general terms, major ice fields actually exert a certain amount of gravitational pull. They actually draw ocean water towards them. And when those ice sources melt, that water, yes, it enters the ocean, but it actually decreases or even eliminates that gravitational pull. So it actually, some of the ocean water draws away from it. It seems counterintuitive that you're getting all this extra freshwater input into the oceans. But it's been an interesting way that scientists have been able to help determine how much water we're starting to see coming into the oceans, not just from here in the North Pacific, where we have a lot of water input from Alaska's glaciers. That water input is contributing to a relative decline in the eustatic level in this area. Seeing, a kind of a similar thing down in of course, Antarctica near Greenland as well. But another really interesting factor in this region is what happens during, yes, the natural El Nino Southern Oscillation or ENSO cycle. Generally during the ENSO cycle, particularly in the El Nino phase, our sea level is considerably higher than average. And so what happens is when you get storms, I'll talk about this next, during those higher sea level periods, those storms become more severe in terms of the wave height and the damage to our coast. The opposite is true during La Nina. And so I'm really focusing my presentation on sea level rise, but talking about El Nino does bring to mind the other issue with respect to shoreline change, and that is coastal storms. There still is some uncertainty about what climate change might mean for the frequency or severity of coastal storms in this region. But there is some evidence that we are seeing a trend over the past few decades of increasing wave heights and wind strength. Now, even without sea level rise, that means that the impacts of these storms on our shorelines is going to be more significant. The opposite is true, though. Even if we don't see a change in the frequency or intensity of storms, with sea level rise, and this is what was demonstrated in the El Nino, those waves events are more severe. In fact, during the major 1997-98 El Nino at Grays Harbor, they actually measured 48-foot waves at one point. I mean, the height of a 4-story building. And there was, tremendous amount of damage in the region. So it kind of gives you a little bit of a preview of what could become more the norm in the future. Very briefly, some other of these more localized factors that affect ecosystems with sea level rise are very important when you're thinking about some of the local implications. One of them is geomorphology, including sediment transport. There are very natural sediment transport processes in systems, things like the delivery of sediments into river deltas. When we have erosive bluffs that when they erode, sand is sent down and you get beach buildup, down the shores from them. And to a certain extent, those processes can help these systems keep pace with a certain amount of sea level rise. This is one interesting case, I think, it's worth a lot of attention. Since the removal of the Elwood dams, there's been a tremendous amount of sediment being sent down into that delta. Now, it's kind of overkill because there's a lot of sediment that's been kind of building up, certainly not mimicking a natural process. But perhaps over time, it'll be interesting to see whether, as this starts to become, a little bit more normalized, how that will affect the ability of systems down flow from that, keep pace with sea level rise. And then marshes themselves actually have a process called accretion, and that process, either building up organic or inorganic sediments, can as well help them keep pace with sea level rise. And there's some indication in some marshes that a little bit of sea level rise actually accentuates that process up to a point. So there are a lot of studies to just try and figure out what the trends are and see whether some types of marshes might actually have some resilience in that perspective. But in terms of the impacts, obviously, I talked about a lot of differences in terms of the sea level projections and the trends, and it depends on this, that, and the other thing. Well, actually, in terms of what sea level rise and shoreline change means for human communities and ecosystems, you have to say the same thing. It kind of depends on a lot of factors. For example, take coastal erosion. It's one of the things that you hear probably most about when you think about sea level rise. Our shores are going to erode. And of course, shorelines across the world, including here, many of them are naturally dynamic systems. Erosion has been a natural process. Places like Cape Shoalwater are better known as Washaway Beach. I just can't imagine building there, but it's been eroding. Erosion has been a natural process there. Now, the real concern with sea level rise is that erosion is going to accelerate and worsen. And of course, when you have human communities nearby, that erosion places infrastructure at risk, and it can affect human well-being, put people's lives at risk. It also certainly can affect many of our habitats as well. You see dunes that have been eroding. Another of the consequences of sea level rises is inundation and flooding. And essentially, kind of the consequences of this depends on some things as well. Flooding is largely, kind of a combination of things like, the sea level change, but also when you get storm events. You get more inland flooding, things like storm surges. Sea level rise is enhancing storm surge here in the west as well as on the east coast. I mean, Hurricane Sandy was an excellent example of where the storm surge has been exacerbated by the amount of sea level rise that they've seen there. And so is true here. And the graphic there shows basically just the flooding risk that is relative to current and then under sea level rise. And you see for major urban areas here, I don't show the southeast just because we're here, but Louisiana, other places, the risk is tremendously higher under projected sea level rise. But there's also potential for long-term inundation. A lot of our urban areas, places here in Seattle and Olympia, because of their low elevation, as sea level rises, they have the potential to be permanently inundated unless measures are taken to protect them. And then there are also consequences, obviously, for our natural systems, ecosystem function and habitat composition. And again, that depends. We are, in particular, in places like Puget Sound, we can see some erosion and inundation of certain habitats and changes in the composition of habitat. But the ultimate consequences of that is going to depend on things like whether we've affected natural processes like that, river sediment input into deltas that might give them some adaptive capacity. More importantly, things like putting up dikes and seawalls that might prevent those habitats from moving inland as sea level rises. And the impacts will have, very much have implications for, species all throughout the food web, as was mentioned with acidification as well. And I'll show you, I'm just going to share you just very briefly an example of some research that the National Wildlife Federation conducted several years ago. We used a model called the Sea Level Affecting Marshes model. It's a model that looks at the potential changes to coastal wetland habitat composition and extent under various scenarios of sea level rise. And we conducted a study for a number of sites in Puget Sound and the southwestern Washington coast, northwestern Oregon coast. The colors on the left, this is basically the map that we show for our initial condition. The reds are dry land. The orange there is brackish marsh. The various kind of greens are different types. Fresh marsh, the light green, and salt marsh closer to the ocean. There are tidal flats and estuarine beach there. And then I'll show you this map on the right because it shows, actually it's a map that shows some historic areas in this region actually, have been historically tidally influenced in the past. So the problem is, as I'll show you in this Google Maps image, that a lot of those areas that had historically been tidally influenced, kind of the light green, is now diked and agricultural. And the key issue there is that here we are in our modeled results under about a 2-foot projected sea level rise, which is plausible within this century, that a lot of that important habitat essentially just gets pushed up to those dikes and disappears. We lose a lot, especially a lot of the brackish marsh. A lot of the beach area is gone, turns to tidal flat. And that's going to change the function of those systems. And this is a similar picture throughout much of Puget Sound. We've already lost a tremendous amount of important coastal wetland habitat in this region for various reasons. So there's real concern about their vulnerability over time. What to do about sea level rise? 2 words. It depends. One of the things that it depends on is, frankly, your time frame. If I were making a decision to rent a beach house this coming winter, I really don't think I would be putting, sea level rise by 2080, into that calculation. Hurricanes are another matter. But if I were going to purchase a house on the shore, say for my retirement, long-term sea level rise is going to be a factor. I'm not going to do that. It also depends on the level of acceptable risk you might have. There are cities like Seattle that are looking at replacing, major seawall. It's expensive to do that. It's probably more expensive to build a big one versus a medium-sized one. What's the lifespan of that infrastructure? If you really want that infrastructure to last for 80 years, you might want to start looking at those higher-end sea level projections. If it's only going to last 30 years anyway, and you're going to have to rebuild it, maybe not. Similarly, I think the other big issue for me is, the irreversibility of potential impacts. If we have endangered species that are at risk, and we don't prepare and help them, survive potential future sea level rise, then they could be lost forever. And I think the same thing goes to thinking about places to protect for those species. It may not be that our coastal areas further inland get inundated fully until the middle of the century, but if we don't do anything to protect some of that possible land now from development, what's going to prevent that development from happening? It's going to be a lot harder, if not impossible, to ensure that we have that habitat and that land available for those species in the future. So all of these things are kind of it depends. There's no one answer, but these are the kinds of issues that decision makers are having to grapple with respect to preparing for sea level rise. And so that's basically sea level rise in a nutshell. Yeah, thank you.